Hi, and welcome to our 18th test and measurement video. Today we'll take a look at the built-in spectrum analyzer in the amazing Tektronix MDO 3104 oscilloscope. We'll be seeing two interesting frequency domain displays for sine wave and square wave. Tektronix calls this series 3000 oscilloscope a 6-in-1 instrument, by which they mean that in addition to an oscilloscope, it is also a spectrum analyzer, logic analyzer, function generator, digital voltmeter, and protocol analyzer for serial data buses. Right now, in addition to the oscilloscope, we're going to use the arbitrary function generator to create a high-frequency signal, and the spectrum analyzer to examine the signal in the frequency domain. It is to be emphasized that this display is not a result of fast Fourier transform, or FFT, that is part of the math functionality of the oscilloscope. Instead, it is a true RF acquisition. We'll also create a spectrogram of that same signal and see what is revealed. To begin, connect one end of a BNC cable to the AFG output on the back panel. Connect the other end to the channel 1 port on the front panel. Push AFG, the bottom button in the column above the channel 1 analog input port. If the oscilloscope has been defaulted since its last use, you have to start from scratch on the AFG. Press waveform and make sure that it is highlighted. It can be altered by turning multipurpose knob A, and you can watch the waveform to see the frequency change. This is a slow process, even with fine turned off. A quicker way is to use the keypad. Type in 50. As soon as you type the first numeral, a units menu appears. Press megahertz, and now you have the high frequency. Shift the BNC cable over to the RF input port. The RF adapter must be in place. Now press RF to access the spectrum analyzer function of the Tektronix Series 3000 6-in-1 instrument. The irregular trace at the bottom is the noise floor, which is not really part of the signal. The high spike at the left represents the sine wave. Amplitude is shown as power in the logarithmic decibel scale on the y-axis, and frequency is shown on the x-axis. Since it is a sine wave, all the power is concentrated at the fundamental, with no harmonics. Directly below the RF button, now illuminated, is the frequency span button. Pressing it, a new menu appears, and if you push R to center at the bottom, the amplitude spike moves to the center of the screen, making the display more readable. Once again, press AFG and change the waveform to square wave using multipurpose knob A. Notice that the spectrum analyzer suddenly shows copious harmonics, large spikes that are positioned outside of the fundamental. This is a consequence of the fast rise and fall times. Pressing RF again, a horizontal menu appears at the bottom of the display. Press the second soft key from the left, labeled spectrogram. This generates a vertical menu at the right of the display. Toggle spectrogram to the on setting. Notice that the spectrogram takes time to fully load. As we have seen, the spectrogram is a subdivision of the spectrum analyzer, not a separate instrument. We'll be examining it in a future video. Thanks for watching. More videos on today's amazing oscilloscopes are coming soon. Check back frequently.